grade 12 learners. Welcome to today's mathematics lesson. My name is Tabang Mapotsani. This lesson is brought to you by the Northern Cape Department of Education in collaboration with Pagama Research and Development. Now, grade 12s, in today's lesson, we are focusing on paper 2 revision. We are now specifically focusing on part 2 of this revision. In this revision, we are focusing on analytical geometry and Euclidean geometry. Now, by the end of this lesson, remember, you must be able to identify the structure for paper 2 and focus on the following topics. So we are focusing on analytical geometry as well as Euclidean geometry and measurement. Now, the topics for paper 2. In today's topic, we are focusing on analytical geometry, which weighs around 27% of our paper, which is 40 marks, and Euclidean geometry and measurement, which is 27% again, and that is 40 marks. So analytical geometry, it is found on question 3 and 4, and your Euclidean geometry and measurement, it's on question 8, 9, and 10. Right, now this is question 3, which is analytical geometry. So I'm going to give you 15 minutes to complete this activity. Right, welcome back, grade 12s. Now let us discuss the solutions to this activity. Now, in this activity, we are told that in the figure, L, it has coordinates of -4:1, S has coordinates 4:5, N and N has coordinates -2 and -3, are the vertices of a triangle having SLN as 90 degrees, and the intersecting LN intersect x-axis at K. Right, so in the first question, we are required to calculate the length of SL. Now, let's focus our attention on the solution for SL. Now, to find the length of SL, so SL is from here to there. So to find this particular length, what are we supposed to use? We're going to use the distance formula. So our distance formula in this case, it says the distance formula is the square root of it is a square root of what? It is a square root of x1 minus x2 squared plus y1 minus y2 squared. Right. This applies. You can actually use them vice versa to say x2 minus x1 and y2 minus y1. What's important here is that if you start with x1, you must also start with the y1 on the other side. So that's what's important with regards to this formula. So now, to find the distance of Sn, so what we did under the solutions is the following. So we have the following to find this distance. Number 1, we find that our SL is equals to the square root of XS. So it has the X value of S, so which is that 4, minus XL, the X value of L, and plus YS minus YL squared. Now this is how you do it. Now you know that XS is 4, it's 4 minus into XL is -4, -4 close bracket plus another bracket squared, plus into the Y value of S is 5 and the Y value of L is 1 squared. We press our calculator, we get our SL distance as 4√5 or 8,94 units. Now, let us move on. 3.2. 3.2 says, calculate the gradient of Sn. So where is Sn? Sn is the length from that to there. In this case, the gradient of S and L, remember to find gradient, just made a mistake there, apologies. It's to say y2 minus y1 over x2 minus x1. So that's how we find the gradient of Sn. So in this case, it will be y2, maybe let's say our y2 in this case, or our second coordinate is S. We'll say y2 is 5 minus y1 is going to be 5 minus into -3 all over x into 2. Right. Now, the solutions are as follows. So we start with the y value. So it's 5, which is the first y value, minus negative to negative 3, which is the y value of n, over 4, which is the x value of s, minus the x value of n, which is negative 2. Then we get our Sn as what? As 4 over 3. So that is the gradient of Sn. And we can see, let's go back a bit, we can see that this gradient is positive because the line is increasing. So the positive gradient, it also shows that the line is increasing. Now we must always check our gradient and compare it with the line that we are working with, just to verify if we haven't made any mistakes. If by any chance you find your gradient to be negative and you are seeing that this is an increasing function, then you go back to your calculations and try to work around that. Now, the question 3.3 says, calculate the size of theta, which is the angle of inclination of Sn. So, theta is the inclination of Sn. You can see that that is where, so the theta is formed when Sn is inclined from the x-axis. So this is the theta we're looking for. To find this, remember, we'll say tan theta, it's equals to m, the gradient of what? Of Sn, because that's where we find our angle of inclination. So in this case, we'll say m is equal to tan theta, that is the formula we have, and that tan theta, we're saying m Sn, it is the m of Sn in this case. So mSn is 4 over 3 as calculated from the previous question. So tan theta is equals to 4 over 3. The 4 over 3, remember, it's our mSn. Thereafter, we now find the second function. So second function of tan theta, it will give us 4 over 3, which is now 53,13. So the angle here is 53,13 degrees. Now, let us look at 3.4. 3.4 says, calculate the size of L and S. L and S. So we're looking for this angle. How do we know that? Also, remember the notation. The one that has that smaller curve there. So it says L and S. So this one is the one that we are looking for. So it's L and S. So we're looking for this angle. Now, how would you find this angle? Now, let us look at this. We can see now that this angle is found in the bigger triangle and we can find it in this triangle. So there's two things we can do, or there's a lot of options we have, but here what we can do is we can find this angle. And how would you find this angle? You'll notice that this angle theta is equals to that angle. So these two angles are equal. Why are they equal? This is what we call vertically opposite angles. So these are vertically opposite angles. So that is to say theta, so our theta in this case is also equals to KON. What is the reason? It's vertical opposite angles. So we have that already, and we know that this plus this, we can see, we can find this angle again here using what? We can find this angle using tan theta, it's equals to m ln. Then when you find this angle, we can simply just use the exterior of an angle triangle. It's equals to the opposite interior, or the sum of the opposite interior angles. That means this angle, which is our LKO, is equals to what? It's equals to the sum of angle LNS plus angle KON. So this angle is equals to this angle plus that angle. So it is that what you can do with them. Now we can say, remember, KON is equals to theta. Why? These are vertically opposite angles. So vertical opposite angles are equal. So that is to say, this angle here, it will be 53,13 degrees. So that is the value of that angle in that case, because they are equal. Now, like I said, we'll find this angle that exists between LKO. How do we find it? We need to find the gradient of Ln first, because we're saying to find that angle, we'll just need to find what? The gradient of Ln. So when you find the gradient of Ln, we're saying MLn between L and N is equals to negative 2. We substitute into the formula there. We can see that this is the y coordinate for L minus the y coordinate for N over the x coordinate for N minus the x coordinate for N. So what do we do? Remember, this together must belong to one coordinate. So this is L, this is the coordinate, this is the coordinate N. Very important. Remember that when you're arranging your formula, it must not be the other way around. If you started with the y value of N, L for example, on this formula, that means you must start with the x value of N also, or when you go to the denominator of L also. Right, we find that MLN is how much? It's -2. Then now 10 LTKO, which is this one, is saying it's 10 LKO is equals to -2. So it's equals to what? It's M is the gradient of what? Of Ln, which is that -2 in this case. So it's equals to that. Then we find that when you do the second function, when you're saying LKO, it's equals to the second function of tan, which is -2. We find a negative answer, which is -63,43. When we have a negative answer, what do? We add 180. So we add 180 to get a positive angle. We get that it is 116,557. Now, when you proceed, remember now we found this angle. We found that this is 116,57. Now we can see this is the exterior angle of a triangle. Remember the exterior angle of a triangle? That's how it looks. This angle is equal to this plus that angle. So that's what we are doing in this case. So this is the angle we're having. It's equal to the sum of the opposite interior angle. That's what we're saying. We now say LNS plus KON. That means this angle plus that angle is equals to 116,57. This 116,57, it is our angle that we find there, which was LKO. So that is our angle that we have. It is equals to LKO. What is the reason? An exterior angle of A equals to the opposite interior angle of a triangle. Then we find that, remember this was 53. So in this case it was 53. LNS plus 53 is equals to 116,57. We transpose this to the other side, which is that 53 we're having there, because remember KON is 53 degrees, 13 degrees. Then we get our, so in this case now, after we transpose that, what do we now do? We now get our angle S. Let me just remove what I wrote there, so you can find the angle that we get. So we get the angle S 63,44. So that's what we get as a result. So our LNS is 63,44. Simple. Right. Now let's move on. Question 3.5. 3.5, it says, determine the equation of the line which passes through L and parallel to SN. So there's a line that is passing here, but this line is parallel to SN, so it's parallel to that line. So there's a line that is passing here, which is parallel to this line. Remember, what do we know about parallel lines? The parallel lines have the same gradient. So the gradient of MSN, it's gonna be what? It's gonna be equal to the gradient of M. I'll just say M, which is this line here. I'm just gonna call it M in that case. So this gradient are equal. Why? Because parallel lines have equal gradients. Now what do we know now? Remember, like I said, MSN is equal to M. So which is this line I have. It's what? They have the same they have the same gradient. Why? Line parallel to SN. Now we know that we are looking for the equation in the form of y is equal to mx plus c. Now what do we do in this case? We now say y equals to mx plus c. Now in a space of m, we substitute 4/3. We have substituted 4/3 there. X plus c. Then we find c. To find c, remember, we substitute any point that is found on that line. So remember, we are concerned with finding the equation of this line. This Sn helps us to find the same gradient. We are looking for the equation of that line. So to find the equation then, what do we now do? What we do now is the following. We now say, okay, we now have the gradient. We need to substitute any point that exists on this line. So which point is that? We are told that the line passes through L. So we're substituting L because the L is the point that is on the line. So that's why we're substituting L to find the value of C. So when you substitute L, the X value is -4. So when you're seeing X, you put -4. When there is Y, you put 1, +1. Thereafter, we substitute. We find our C as 19/3. Thereafter, now we write our equation in full, which is now Y is equals to 4/3x plus 19/3. So that is the equation of the line that we are having in that case. Now, look at this one. Question 3.6. It says to us, calculate the area of triangle LSN. Where is that triangle? It's L. Start from LSN. So the triangle or the area of that triangle. Right, how do you find the area? Remember, to find area, it's equals to half base times perpendicular height. Do we have perpendicular height in this case? Yes, we do. We have our perpendicular height. So what is the perpendicular height? It is SL. Then we have a base. A base is what? LN. So in this case, our area will be 1/2 of the base is the distance of LN or the length of SLN multiplied by the perpendicular height, which is my SL. Right. So that's how we're going to find that in that case. Now we need to find, remember LN, we need to find LN, we need to find SL. Now what is the distance of SL? SL, our distance as SL is what? Is 4√5. I think this was calculated in the first question. Then the distance of LN, it is between L and N. We now start by saying x2 minus x1 squared plus y2 minus y1 squared. Now we're saying this is the x coordinate of L minus into the x coordinate of N squared plus the y coordinate of N. So remember, this is for N, this is for N. Y coordinate of N with L, sorry, which is 1 minus the y coordinate of N, which is -3 squared. Then we find that Ln is 2√5 and we have 4√5. Then the area of triangle LSN, it is now given as half. Our base in this case, as I've mentioned, is Ln. So it is Ln, which is that of 2√5, the distance of Ln or the length of Ln, into the perpendicular height, which is my SL, which is what? 2√5. Then the area of LSN is how much? It's 20 units squared. Right. So we are moving. Now 3.7 reads as follows. Calculate the coordinates of point P, which is equidistant from L, S, and N. Very interesting. Coordinates of point P. So P is equidistant from L, S, and N. What does this mean? This means to us, P, it must be somewhere that when I move from P to S and I move from L to N, P to L, when I move from P to N, it is the same distance. So the distance here and the distance here must be the same. When I move from that P, that means P must lie at somewhere here. But we'll prove that why P must lie there. So it must lie there so that P, it actually becomes a center of a certain circle where all of these distances will be the same. So you can draw a circle there. So P must be the center of all of those so that we can have an equidistant from rule. So you can have, say, this length and this length, all of these lengths are equal. So that is the reason why P must be at the center there. Right. Now let us look at the solutions to this. Remember, L is equals to 90. We are told that L is equals to 90. If now L is equals to 90, therefore SM must be a diameter to a certain circle. Why? Because we have angles in the same circle. So it's the converse of that diameter to say, of that theorem to say now, if this is 90 and this is, we should have a circle here. whereby this Sn must be what? This Sn must be the diameter to this circle. If Sn is the diameter to this circle, therefore P will become a center. Now when P is a center, we now use the formula for the center to find the coordinates of P. Remember, to find the coordinates of the center, P, in this case, it will be P into, so it's going to be x value of, so we'll start with say x value of S plus x value of N, because P must lie on Sn. So P must lie on Sn so that these distances are equidistances, given that this angle is 90. It's an angle in a semicircle. All over 2 is 2 ys plus yn all over 2. So that's how we'll find the coordinates of P. So now the xs, we can see there is 4 plus -2, which is the x value of n all over 2. And we have the y value of s is 5. So that's 5 there that we have, plus -3, which is the -3, which is the y value of n, then over 2. Then we find that 4 minus 2 is 2, 2 divided by 2 is 1, then 5 minus 3 is 2, 2 over 2 is also 1. So P is 1 is to 1. So it is the center of a circle in this case. Right. Now let us look at 3.8. Now 3.8 says to us, calculate the size of L. It's L, P. Oh, there's P there. Remember P. There's a point here. So P was 1 is to 1. Right. Very important for us to remember that. So P was 1 is to 1. What do you notice? You notice that this line will be straight. Why will it be straight? Because they share the same y value, which is 1 at that point. So that's why the y values are the same. You can see that this line is actually parallel to the x-axis. Now, automatically we have a certain idea. So it's LPS. So we're looking for this angle. And we can see that these lines are parallel to each other. So when we have parallel lines, what can we now see? We can actually think of a certain situation. Remember, parallel lines, it means you must have fun. You must have fun. You must have fun. When we have fun, we talk about corresponding angles, we talk about interior angles, we talk about alternate angles. So that is fun that you must have there, meaning you must look for any of this shape, whether an F shape, U shape, or a Z shape or N shape. In that case, Z, however you put it, you must have that. So that's why I'm saying parallel lines have fun. When you can check the following, you can see that there is a Z there. That means this angle and that angle are equal. They are alternating angles. So that means this angle there is theta, which is 53,13. Then when you have that angle, automatically we can now see that this is a straight line. So this will be angles on a straight line. So this was a very interesting question. Now this is what we're saying. LPN. So this angle that I've indicated here, which is the one that is forming the Z, is equal to theta. It's equal to 53,13. Y alternate angle Y. LP is parallel to x-axis. So LP is parallel to x-axis. We have alternate angles. Thereafter, what are we going to now say? We're going to now say, let me just add to this just to show how we got the solution. We'll say LPN plus LPS is equals to 180. Why? These are angles on a straight line. So those are angles on a straight line in that case. So angles on a straight line, they are supplementary. Then LPN, we have it already as 53,13 plus LPS is equals to 180. Then our LPS is equals to 180 minus, transpose that to the other side, or minus by 53,13 both sides. Then we have LPS as 126,87, which is what we have the SLPS. So this is the working out to that LPS. Now grade 12s, I will give you 15 minutes again to complete this question. Right, welcome back, grade 12. Now, let us discuss the solutions to this activity. Now, we are told that in the diagram, O is the center of the circle with the equation x squared plus y squared equals to 20. Now, this is O is the center. So, this is the angle that has an O as the center. So, the equation, this is the equation for the small circle. G, which is the coordinates t is to 0, is the center of the larger circle. The common tangent touches the circles at D and F. So there's a tangent that touches the circle at D and F respectively, such that D, which is coordinates of D, which is P, is to -2, lies on the fourth quadrant. Now let us calculate. Let's look at 4.1. 4.1 says, given that D, its P is to -2. So what is P? So that's our P that we're having. P is -2, is lies on a small circle. Show that P is equals to 4. So it is lying on a small circle. So what can we say? We know that the small circle is what? It's x squared plus y squared equals to 20. So we'll substitute D, because this D lies on this circle to -2. That means whenever this is x is to y. Whenever we see x, we put P. When you see y, we put -2. That means when there's x, we have x there. So it's going to be P squared plus our y. So our y value in this case is -2 squared is equals to 20. Thereafter, we now know that P squared is equals, or P squared plus 4 is equals to 20. Then we transpose that P squared is equals to, when you minus by 4 both sides, you have 16. Then P is the square root of plus or minus root 16, plus or minus root 16. So P is equals to plus or minus 4. Then we proceed. So those are the solutions to that activity. So now, like as mentioned, so now we can see for these solutions, we say in D, it's what? It is P is to -2. Thereafter, we now say substitute D in a small circle. Why? Because D lies on the small circle. Then when there is P, this is X is to Y. When there is P, you put, when there's X, you put P. Then when there is Y, you put -2. Then we solve for P. So P is plus or minus 4. So this is square root of plus minus. Remember, when you need to use a square root, it's a plus or minus. Or we can just say P squared minus 16 is equals to 0. We now apply a difference of 2 squares here. So P is plus or minus 4. But let's check where is P. P is on the fourth quadrant. And they said, if you can see, they said D lies on the fourth quadrant. So on the fourth quadrant, we know that X values are positive. So that means P is equals to +4. Right. Let's look at 4.2. 4.2, we're told that E, which is 6 is to 2, is the midpoint of DF. So E is the midpoint of DF. Determine the coordinates of F. We have D. Remember our D, it was that 4 is to, it was 4 is to, let me just go back a bit, just remind ourselves, -2. Remember, we found P as 4, then it is 4 is to -2. So -2, we have E now. So we're told that E, it is 6 is to 2. So what are we looking for? We're looking for F. So E is the midpoint. So when you're using the E as a midpoint, in this case, we'll now say, remember, if E is the midpoint, we'll say E, coordinates of E are given by X value of, it is the X value of D plus the X value of F over 2 is to the Y values again. So we'll find that the Y values of D plus the Y value of F over 2. So if E is the midpoint, so that is how we find the coordinates of E. Now we find that, okay, this gives us, the first one, it gives us the X coordinates of E. So this gives us the X coordinate of E. And this will give us the Y coordinate of E. Now, so what do we now do? We know that this is the first part, which is what I do there. This I said it gives us the X coordinate of E. That means this is equals to XE. So XE now, it is what? XD plus xf over 2. So xd is what is 4. Xf is what I'm looking for, over 2. Then the x coordinate of E is 6. So it is equals to 6. Then xf, we solve it, is 8. Then we come to the y part. So the y part, remember the second part, we say this, it is what? Yd plus yf over 2. It will give us the ye. In this case, it's equals to ye. Then ye is, this is the e value. So this is ye. This is what we call, that was our xd. Then we find our yf as 6. 8 is to 6. Let's proceed. Determine the equation of the common tangent df in the form of y is equals to mx plus c. Now, the equation to the tangent df, so the tangent of df, so we need to find, first thing that we need to do is to find the gradient of df. So the first step for us to find the equation of that line, we'll now find mdf. So we find the gradient of df, then we'll substitute that, we'll substitute any point that lies on that to find our values. Now, first step, we'll find the MDE or MDF, doesn't matter because DEF are collinear points. Whether you find DF, MDF or MDE, you will find the same value. So if you use D and E, you will find 2. Even if you use D and F, you will find 2 because we have all of those coordinates now. Thereafter, we substitute, this is the equation that I've used here, the one of saying y minus y1 is equals to m into x minus x1. Now, what we substitute, any point that is on that line to find the equation of that line. So any point, which point did I substitute? This is point D. So this is point D that I substituted here. So you can substitute point D, E or F because they are collinear and they are all lying on the line. So any point, so we substitute the y value of D where there is y1 and x1. Or you could have just said y is equals to mx plus c. Y is equals to 2x plus c. The 2 is our gradient in this case. Now substituting any point, you can substitute D again. When you substitute point D, remember it was 4 is to negative 2. Then the y value was negative 2, it's equals to 2. What is our x value? X value is negative 2 again plus c. Then what we now see? We now see negative 2 is equals to negative 2 times 2 is negative 2 times 2. So this is the x value. Oh, the x value is 4 there. It's positive 4, not even negative 4. Positive 4. 2 times 4 is 8 plus c. Transpose that is negative 2 minus 8 is equals to c. Then our c in this case will be how much? C will be negative 10. Then when we substitute into that equation, it's y is equals to 2x minus 10, which is what we have there. So you can use this method or that method. This method gives you the answer straight away because you will now say times 2x times that is negative 8. Then this gives us a positive 2. When transpose the 2 to the other side, it becomes a, when transpose the 2 to the other side, we'll get y is equals to 2x minus 8 minus 2, which is negative 10. Right. We are told that calculate the value of t. Where is t? T is the line that is lying on the center of the circle or the center of a bigger circle. Now, how would you find that? You can see that t also lie on this equation. So 2 points, 2 options in this case. You can find the equation of fg. How would you find it? You can find its gradient first. How would you find the gradient? This is tangent perpendicular to that because this is the center. So tangent perpendicular to radius. So we know that m df multiplied by m fg, it will give us negative 1. Why? Tangent perpendicular to radius. So that's what we'll do. That's how we'll find the m fg in that case. Now remember m df is equals to de, like I said, is 2. Then mgf, it will be negative 2. How do we find that? It is this formula that I've used. Then df for de is 2 multiplied by mfg, it's equals to negative 1. So divide by 2, divide by 2. We find that mfg is now equals to negative 1 over 2. So 10 to 10 perpendicular to radius. Thereafter, we can use the gradient formula. Remember, gradient will say mfg, it will be y2 minus y1 over x2 minus x1. Now, what we now have, we have the gradient already is negative 1 over 2, which is what we have there. It's equals to y2, our y2 will say 0, which is the g, minus y1, in this case y1, which is the coordinate of f there, which is 6 all over. Then x value there is t minus our y value there was 8. Thereafter, we solve for t. Just cross multiply them. Then we find that t is how much? It's 20 units. 4.5. We are saying in the diagram, oh yes, determine the larger circle in the form of x squared plus dy squared plus cx plus dy plus e is equals to 0. Now, how would you find it? We now know that we have the center. Our center of the circle is g. It's what? It's 20 is to 0 because t was 20. And we have a point on the circle which is f. So our f was 8 is to 6. Now, how would you now find the equation of that? Remember, the equation of a circle is x minus a squared plus y minus b squared r equals to r squared. Now, what are we doing now? We find the r squared using that. How do we find it? We substitute a center. So what is our center? Our center is a and b. So in that case, it's going to be x minus our a is going to be the x value of a center, 20 squared, plus y minus our b, in this case is the y value of the center, 0, is equals to r squared. Thereafter, we substitute any other point, then we substitute f after. When we substitute f, we say the x value now, we're putting f now here. When we substitute that, now the x value of f is 8 minus 20 squared plus y is how much? Our y is 6 minus 0 squared is equals to r squared. So I was just explaining how this was substituted into. Thereafter, we find that we just put in a calculator, we find r squared is 120. Now we go back and put it into an original formula which says x minus 20, which is the center, plus y squared, because the y value of the center is 0. Thereafter, we just expand the first bracket. Then we find x squared plus gonna be x squared minus 40x minus 220, I think. Yes. Thereafter, what we do now, we distribute that. After I distribute that, we add like terms. So in this case, what are we gonna have? We're gonna have this situation. We're gonna have x squared minus 20 negative 20 is negative 40. 20 times 20 is 2 times 2. It's 4. That's gonna be our 400. It's 400. Thereafter, what do we now have? We now have plus y squared equals to 180. Then after like terms, we have the 180, transpose 180 to the side, so it's 400 minus 180, we get 220 in that case. Then 40x, still have it there. Then we now find the equation in that form. 4.6. The smaller circle must be translated by k units along the x-axis to touch the larger circle internally. Calculate the possible values of k. So what are we saying in this case? We are saying this circle must be moved so that it touches this here. The smaller circle must be translated so that it touches that here, or it touches it here. So those are the two options we are having. So it either touches this side or that side. So that means this coordinate will touch here. So I'm just going to say x and x. They will touch there, or this y part will touch with that there. So those are the two parts that must touch. So the first k value will be that, and the second k value must be that. So that means we must find this coordinate on the large circle. We know that we must find the radius first of that line, then we can find this coordinate and the radius of this larger circle. So the radius of a smaller circle r is 2 root 5. We know that the distance, because it starts from 0, from here to here, it's negative 2 root 5. Then from here to y, it's what? This side, it is also 2 root 5. Now, the larger circle r, so we are saying now, from this value that I have of g, we'll minus the 20 to get this first coordinate here. So to find the first coordinate of x there, we'll now say our g, remember our g was 20 is to 0. So I want to find this coordinate. I will minus the radius on the x-axis here. That means to find this coordinate is going to be 20 minus the radius of a larger circle, which is what? 6 root 5. That is the first coordinate, x coordinate, and the y coordinate is obviously 0. So we have that coordinate. Now, what is the k now? Remember, the k must touch, these two must touch. So it will be the first coordinate there, which is my 20 minus root 5. So it's 20 minus root 5. It will give us that coordinate minus into negative root 5. Which one is negative root 5? Because if this must touch internally, then r must be minusing that r in that case. So what are we saying in this case? Now, what are we saying? It's minus the radius of a smaller circle, which is this coordinate. Remember, this coordinate will be what? It will be negative 2 root 5 is to 0. Now we're saying the bigger coordinate of the coordinate of a bigger circle minus the coordinate of a smaller circle, the x coordinates, because it will be shifted x ways. So that k there, it is our x of a big triangle, big circle, sorry, minus the x of a small one. So the x coordinates only. So the x coordinate of a big one, it is 20 minus root 6 root 5, which is that radius of that circle. And remember, this one, it was from 0, so it's just negative that. So that's what we did there. So the x value there was that, and the x value was that. Then that is the first k unit. Then the k is must be, that is the one that we must add in this in order for it to be translated to get to that point. It's 11,06 units. Or the other one, when talking about the bigger one, so the x value here was already 20. So we're going to say the x value of the big triangle, x value of the big minus the x value of the small. Now the x coordinate. So the x coordinate of the small in this case, because it starts from 0, it is 2 root 5 is to 0. Because the y coordinate there is 0 in that case. Now, what do we now have? The x1 is what? It's from that, it's 20 plus root 5. So it's 20. So to get this coordinate, it will be, that coordinate will be, x value will be 20 plus the radius, which is now 6 root 5 is to 0. The y value there is 0. Then this one, remember, is that one. So we say the x of the big triangle minus the x of a smaller triangle. Then we get k is 28,94 units. So that's how we find the value of k. Remember, how do you find this r? This, we have the equation of a smaller circle there. So if we go back and revise the equation of a smaller circle, the smaller circle, the r squared is 20, and the bigger circle is 120. So the big circle is 20, and the r1 is, so this one was just a root of 20 to get r, because it was r squared. Then this was the root of 180 to get that r in that case. Now, grade 12, let's take a break. We will meet again after break to discuss the Euclidean geometry.